Imagine a material that's as rigid as a steel beam when you need to support a bridge, but as soft as a silicone sponge when you need it to bend. For a long time, engineers had to choose one or the other. The problem is fundamental physics. Materials are usually locked into their state, solid or liquid, based on the environment. Changing that typically requires massive amounts of energy or clumsy mechanical systems. But in February 2026, a team at Duke University changed the game. They've engineered a composite that can toggle its stiffness instantly, and the way they did it is absolutely brilliant.
Traditionally, if you wanted a robot to be both strong and flexible, you had to use complex hydraulics or heavy motors. This added weight and reduced efficiency significantly. This is the soft robotics dilemma. Soft robots are safe around humans but can't lift heavy loads. Rigid robots are powerful but dangerous and inflexible in tight spaces. The Duke team realized they didn't need a new robot. They needed a new kind of matter, a material that could transition between these two worlds at the speed of an electrical pulse.
At first glance, it looks like a simple gray block, but under the surface, it's a sophisticated mix of gallium and iron particles, arranged in a very specific way. This isn't just a random mixture. The engineering team had to figure out the exact ratio to ensure the material remains structural while solid, but completely fluid when triggered. The result is a material that can change its Young's modulus, that's the measure of stiffness, by several orders of magnitude in less than a second.
When you see the material in action, it's like watching magic. One moment, it's holding up a heavy weight, and the next, it's flowing through a narrow tube like water. But the really clever part isn't just that it melts, it's how the engineers use the iron particles to keep the material controllable, even when it's in its liquid state. This control is what allows the material to be programmable. You're not just melting it, you're telling it exactly how much to resist movement.